Hello, my name is Micaeli Dym, and I investigated the effect of different media-based vertical hydroponic systems on the wet biomass of Brassica oleracea. Hydroponics is a new type of gardening that uses water supplemented by nutrients instead of soil to grow plants. Some advantages this has over conventional growing are that it can be done indoors and uses much less water and resources. One of the most popular forms of hydroponic growing currently is vertical hydroponics. This method allows for much less space and therefore more plants to grow at once. There are multiple variables that can be changed within a vertical hydroponic system to affect the results of this system. One key variable of a vertical hydroponic system is the medium in which the plants are grown. Some media are more cost-effective than others or can be more environmentally friendly. One common type of media used in vertical hydroponics is expanded clay aggregate or clay pebbles. This is a light media which works well to keep roots oxygenated and is environmentally friendly. It has been used for many years by small hydroponic farmers. However, in recent years, hydroponic suppliers have introduced a new foam-like media instead. This reusable media has a higher biological surface area, allowing for better nutrient absorption with better plant support. Currently, there is a shortage of water and other resources necessary for growing fresh produce across the world. In addition, less cultivable lands are available, and climate change has affected the growth of plants in soil. Therefore, hydroponics has become a more viable option for farmers. Vertical hydroponics, in particular, could be much more effective in providing fresh fruits and vegetables in places where there is not fruitful soil or large water supplies. Finding a sustainable medium that yields produce the most efficiently could help source a more reliable and effective food supply to tackle food scarcity across the globe. The objective of this experiment in particular was to compare vertical hydroponic towers using two different growth media, expanded clay aggregate and filter foam, in the same growing environment to determine which of these two media-based systems produced more biomass in Brassica oleracea, or red Russian kale, in the 6-week growth period. The research hypothesis investigated was that there will be a significant difference in the wet biomass of kale plants grown in different media in vertical hydroponic systems. Some assumptions made were that at least 12 of the 20 kale plants in each of the levels would survive and provide accurate data. Minor variances in nutrient levels, light exposure, amount of medium, and spacing would not impact the biomass of the kale plants. Any variability in the environment would have the same impact on both systems, and any inconsistencies in the design, construction, and implementation of the systems would not have a significant impact on the biomass of the kale plants. Some important materials used were red Russian kale seedlings, water, nutrient solution, buckets, which made the reservoirs for the towers, a vinyl fence post, which was used to construct the clay-based system, a vinyl downspout, which was used to construct the foam-based system, expanded clay aggregate pebbles, and filter foam. Some important equipment necessary were 3 LED strip lights, pH test strips, an EC meter, plug timers, and 2 submersible pumps. The facilities necessary for this experiment were the student researcher's house, where the systems were produced, the plants were grown, and the data was analyzed, and the high school lab in which the data was collected. So first, the clay-based tower, shown in Figure 1A, was constructed using a fence post, and the foam-based tower, shown in Figure 1B, was constructed using a vinyl downspout. Both of these towers were then filled with the appropriate medium, either expanded clay aggregate or filter foam, and 20 kale plants were planted in each tower. Then these two towers were set up in the growing environment shown in Figure 2. The reservoirs of the towers were filled with water and nutrient solution, 3 lights were spaced equally surrounding the towers, and timers were started to monitor when the lights and pumps were turned on. Then the 6-week growth period began. Once a week during this growth period, the electrical conductivity, pH, and water levels of each system were monitored. After the 6 weeks ended, the above-ground growth from both towers, as shown in Figure 3A for the clay-based tower and 3B for the foam-based tower, were harvested. Each kale plant was then weighed, and the wet biomass was recorded. Finally, this recorded data was analyzed. So Table 1, shown on the left, is a raw data table which shows the wet biomass after the 6-week growth period for both the clay-based and foam-based tower. This data was then analyzed for the mean, standard deviation, variance, and number of trials, which can be shown in Table 2 on the right. Figure 4 shows a bar graph which compares the mean biomass for the plants grown in the clay-based system, shown on the left bar, and foam-based system, shown in the bar on the right. As you can see in this graph, the foam-based system has a significantly greater mean biomass than the clay-based. Figures 5 and 6 both demonstrate 3 standard deviation error bars for the plants grown in the clay-based media, shown on the left, and the foam-based media, shown on the right. Neither one of these graphs have any outliers. So the quantitative data used was the biomass of the kale plants grown measured in grams. An independent two-tailed t-test was then applied to determine if there was a significant difference between the two media-based systems. The alpha used was 0.05, and the p-value found was 0.03556. Because this p-value was less than the alpha, the null hypothesis was rejected, and the alternate hypothesis was supported. Therefore, a significant difference was found. So, because the research hypothesis was supported, the data did support that there was a significant difference in the wet biomass of kale plants grown in different media-based vertical hydroponic systems. These findings suggest that there is, in fact, a correlation between the growth medium used in a vertical hydroponics tower and the efficiency of that media-based tower in growing red Russian kale. In this experiment, only 2 growth media were compared. Therefore, in future studies, it would be interesting to compare these growth media to different common hydroponic media. In addition, some media are more cost-effective or environmentally friendly than others, so it could be relevant to compare media based on factors such as these. Another suggestion would be to test multiple systems, all of the same design, with different media in each system. This could determine if it was the media or the hydroponic systems themselves that had the greater impact on the biomass. Thank you for your time.